Good morning, everybody. A pleasant to be here with all the water enthusiasts. Again, my name is Fabio Hüther, and I'm the co-founder and CTO of Evodrop. What I want to represent today is the new era of water softening. We do that with the patented Malic acid technology. As you may know, water softening treatment has never been modernized or updated since many years. They tried it with kind of polyphosphate, but which are environmental harmful and toxic. And now we will show you how it can be done with a bio-based solution, which will not harm human organism or the environment itself. So we are from Evodrop. We are a Swiss company. You're welcome to see all what we have at our booth here at the corner. So far we have 24 patents and innovations. We made over 30 own and peer-reviewed studies and reports. We are winners of over 10 different awards. Like this year we won the Aquatech Award, which was also in Amsterdam. You may know it. It's one of the most renowned awards for water treatment classifications. So everybody knows and is obsessed when there is limescale happening. Most of the issues we don't see because it's happening in the infrastructure itself, in the pipeline. What we see is the scale, the limescale, the deposit out of it, especially in the shower, dishwasher, and so on. But what is happening in the boiler system and in the whole infrastructure is mostly vanished and invisible for us. Interesting is what you see on the left side is that only 1 millimeter of thickness in the piping system will already make the heat efficiency 10% higher. Means you need around about 10% more of energy. With 6 millimeters, it will already be like 50%, especially in areas like where we are in Central Europe, but also in the US. And other markets which are in coastal areas, you have quickly that kind of deposit over a decade. So with these 3 patents, we have the endless potential, especially like nowadays, topics like PFAS removal and for sure also detection, but also the removal is essential. So we have the position and constitution that we can remove limescale or filter the limescale to this decalcification technology and also remove PFAS, microplastic, pesticides, and so on. So this is the combination of these cartridges in the point of use and also in the point of entry, which you see the 2 different models which are developed by us. That's an interesting topic because usually, as you may know, a lot of companies or especially consumers and household owners, they have maybe like ultrafilters or activated carbon filters or conventional obsolete like water softening, which are not able. A few companies claim they can remove PFAS, but most of them just can proclaim that it's the long-chained PFAS and not the short-chained. But in the classification, it's not really diversified if it's short-chained or long-chained. So this is why you really have to be dedicated and questioning what is really the short-chained filtered out or not. We have like third-party approval to do that. The interesting topic is also you don't need any wastewater, but I will come to that point later. And also it doesn't require any electricity or chemicals. This is the ion-sieve Malox technology with this Malic acid you have seen. The granulars you see here on this slide. It's also, we have some samples at our booth where you can test it by yourself. Then it's really a simplistic way of demonstrating how scale or decalcification can work. So usually you have the combination of calcium and magnesium in the water. They combine with hydroxides and carbonates, which you see the CaCO3, for instance, is the most common. It's calcium carbonate. And then you have the magnesium hydroxide. And the Malic acid, which you see on the 0.4, is that it's complexing and chelating around these minerals, which mean we do not have to remove the minerals. And through that chelating and complexing mechanism, it's possible that the minerals do not create any deposit. So they are bonded even through stagnation, even if there is heating or a boiling process up to over 100 degrees Celsius is happening. The bonding and the interference stays connected and bonded. The benefit from that is that you do not remove the minerals, the essential minerals like magnesium and calcium from the water. You don't have a flat taste or a different taste like you have with other when you soften the water, because then you replace magnesium and calcium with sodium, mostly, or kalium. Yeah, it's one principle and infinite potential, as you can see from coffee machines, from showers, from RO tabletop machines, from pitchers, from ice machine, from tea and coffee and dishwasher. The potential is huge. Because usually, as I mentioned before, it's water softening used, so ion exchange at one composition, it works what I mentioned before with sodium, so it replaces the mineral with sodium. So these are the huge ion exchangers. The small works that they just remove the calcium and then replace it with hydrogen ions, and this is why it also then turns corrosive, and the pH drops down to 5 or 6, which here is not so extensive. Here I want to exemplify a little bit more in detail our filtration. On the left side you see the conventional carbon block system, which have mostly macropores. So the macropores are the pores or the element which make it happen that carbon filter can adsorb. So it's not absorption, it's called adsorption. And through this adsorption, it's the potential that you can remove or filter pollutants. What usually is not possible is like heavy metals, for instance. A lot of activated carbon filter cannot remove heavy metals, especially also not like short chain PFAS and so on. And on the right side, you see our Nanoporous Adsorber. And here you see the most element parts are the micropores. They are around about 2 nanometers or smaller and are in a special wet spinning process formed into a fleece and layers, which are connected then also with our PlasmaShield NanoMatrix, which make it happen that you even can remove heavy metals without the combination of KDF or other resin medias. Also, carbon blocks or carbon in general tend to, for germination. So germination can happen because carbon, bacteria and germs are a huge part of carbon itself, and the activated carbon itself helps them to grow because it's like a full fridge for them, let's say so. And so most of them remove then the chlorine through the catalytic process, and then you have kind of not sanitized water, and then germination can come back. This is a huge issue. If you combine it with ultrafiltration and so on, you need to do another steps. But with that technology, you stay germ-free and without biofouling, because it's a redox potential inside and on the surface. This is another patent which you may remember at the second slide I mentioned. This PlasmaShield NanoMatrix, which is also written here, creates a redox potential from different mineral layers, which is so strong that through the surface tension and touch from germs and bacteria kills them instantaneously. Based on the affinity of the customers, we made like different systems and configurations. You see from the left side, it's like only scale protection. So we made certified, which you will see then later, in a third-party laboratory where we could prove that we have like 94.2% of scale protection based on the NSF or the German DVGW. You need to reach 80% of scale reduction to be allowed to say that you soften water. And most of the other system like electromagnetics and ultrasonic and so on, we also tried that, because for us the maxim was also to go as most eco-friendly and sustainable as possible. We tried and we failed, like many others as well, because it's not possible so far with ultrasonic or electromagnetism and vortexing and so on, or that you can remove the scale into such a percentage. It's possible, but like only 20 to 30%, so you will never be certified. Yeah. And then we came across, especially because of the current situation. I don't know how it is in your countries, but in our countries, the PFAS topic is very hot, and it's a hype that people are thinking about it. So like mostly everybody knows now about PFAS in the food, in the water. So that's why we created also a filtration system and combined the solution of scale protection and filtration, like a 2-in-1 version. And on the right side, we just have the filtration for people which say we don't have scale, soft water, So, and it's all fitting in one housing. So here you see the different sizes and circumstances happening from a single house up to multifamily houses, apartments, up to large-scale buildings. It's very easy to do the scale up. We have bigger systems, but we do not really rely on them, and also we do not, tend to them, because the bigger the systems get, the more complicated it will be for the facility management. So we keep it safe and sound and simple for the facility management. So even a man or a woman which is in his senior age is able to replace the filter cartridge without any physical or knowledge strength will be required. So now I want to talk a little bit more about the conventional salt systems, because in our, like the German-speaking countries, it's the most common topic. Like ion exchangers, what you see here in the blue cartridge, this glass fiber tank. It requires a lot of wastewater. For instance, for a 4-person household, you need a few thousand, like 7,000 to 10,000 liters of water, only wastewater, because you need to do a regeneration, because the ion exchanger is replacing the calcium and magnesium through sodium. And because calcium, like a Ca2, and magnesium also Mg2, you need to replace with 2 sodiums. And this means the TDS, so the total dissolved solids, stay similar, just they replace it with the sodium. And this sodium comes from the salt, which you see here in the bag, this salt bag. And through this regeneration, you need to flush that out all the time into the wastewater channel. For instance, California and some other countries already denied and make a prohibition for water softening system because of all the wastewater which is then going back into the environment, which created like a high chloride level. And as we know, chloride is also corrosive and destroying the infrastructure itself. And here the salt, just the sodium goes to you in the drinking water, so you drink then the sodium, and the chloride of the salt will then be also flushed out into the environment. And here, as you see, it's very simplistic, there is no connection to the wastewater. There is no regeneration happening. There is one cartridge. This one cartridge makes up to 250,000 to 300,000 liters in the middle hardness of water. Let's say around about 350 ppm of the TDS. We only require 1 kilogram of malic acid for that amount of water. like 250 to 300,000 liter. Compared to a water softener, you need around about 100 kilograms of salt to have the same effect. So we, as you see in the blue box, we require 100 times less of malic acid compared to the salt. Here we made a comparison. Is now a 12-unit apartment, which you see on the right side in the corner. Even most of the people think, yeah, now you say something very eco-friendly and bio-based. Now, yeah, let's talk about the financials. And most of the people think, yeah, because it's bio-based, it's also like organic food, that it's more expensive, but it's kind of the opposite. As you see, an ion exchanger usually from the renowned companies, for sure, you can also push them directly from Alibaba in China, then it will never be that price. But if you have like competitors which produce it like we, then you have around about 8,000 euros, and we are with 4,600 euros very competitive. The consumption, as I mentioned, because here you see on the right side, we use 2 of our systems parallel installed. We require only 2 kilograms of malic acid, and the ion exchanger requires around about 288 kilograms of salt. The wastewater volume is 0, as I mentioned to you before, and the water softeners require around about 60,000 liters of wastewater. The benefits of the comparison is also that we do not, especially in Switzerland, also like we have here in the Netherlands or in Scandinavia and Germany, so in all these areas where we do not chlorinate the water and people drink directly from the tap, it's very essential that the taste and the flavor of the water stays soft and smooth. And we do not have a change. When you are not tend to drink ion exchange or water softened water, there is a kind of a flat or a salty or a metallic smell, depends on how the ion exchanger work. And with us, you don't have that, right? So in our country, a lot of people have then functional water, we call it so, with the water softening. But the issue is then they don't like the water taste anymore and then buy bottled water. So it's a little bit paradox to say so. There is no corrosion happening because the malic acid, yes, there is the word acid in it, but the malic acid, as I mentioned before, will be transmuted with and interfered with the minerals and then creates a malate, so the salt form of the malic acid, and will not create. So the pK level is at 3 and at something at 5.2. So means if you have a stable pH with 6, 7 or 8, it will not really interfere with the pH, so that the water stays stable. And also there are not any free radicals like hydrogens or oxygens and ozone, etc. happening through this combination. Here I want just to demonstrate, because we are humans, are visual people, so to visualize it, this is like according to this procedure, which also the NSF or the German DVGW and even in Asia, the CTI has. You have usually, it depends on the laboratory, but usually like the European version is you have a 21-day tutorial where you need to install on 2 boilers your system. On the other 2 boilers, they are like for the reference. Then you flush it, like usually water consumption of a private household, between 5, 15, 20 liters a minute. And then you see on the left side the deposit happening on the heat exchanger itself. This then will be removed mechanically, physically, and also with some acids, and then will be put on a weight, and then they compare. And this is how they calculate it. Here are 2 different test versions. On the left side is from the CTI, where we reached 94.2%. It was a little bit more tough test. And on the right side is the German test, where we reached 100%. So yeah, we reached definitely the level what conventional water softenings require. What I sent to you, the border or the the requirement is around about 80%, and with that level, we are more than enough and very feasible. Also, more and more funds or real estate management and facility management requires some of the CO2 savings, the ESG. You may also have the compliance of the ESG, and the policy is also changing a lot. And it's also very fascinating because, nobody was thinking about how you can save CO2 with water. And here they made a study in the UK, which if UK homes would use softened water, and even with a normal water softener, which have wastewater, electricity, and use resins and so on, they could even save around 8.2 billion of kilogram of CO2. So here are some of the labs which we did some tests. We did for sure also what you see on the first one. We did some tests also on the toxicology and also on the human organism and like a cell culture test, because we wanted to know, can malic acid even in high doses harm the human body or even our cells. And for sure, malic acid is also used as food preservative, as a emulgator, like 296. And we could even prove that the malic acid helps cell cultures. So we do not proclaim them. We don't make health complaints or so. But it was interesting to see. Our intention and was to figure out at which level malic acid can be toxic. And what we found is that malic acid even helps gut epithelium and fibroblast cells to grow better and have a better generation, a faster generation, and also helps against inflammation. Some of you may know malic acid is also now a well-known food supplement. And even the interesting part was that if you combine the minerals in the water, soften or decalcify the water with the malic acid, the minerals get, for instance, calcium and magnesium malate. So they are not the magnesium and calcium oxide, for instance, to simplify it now. So they get the malate version. And through that, it's like around about 3.8 times more bio and cell available for the human body than the normal inorganic minerals, because through the malic acid it turns from an inorganic mineral to an organic mineral, which is much more bioavailable. It's the same like if you eat something and you can absorb and the minerals better than from the drinking water itself. The award and recognition, I think it's all said. I think the most impressive award which you can get in our category we won. We are very proud of that, and we also delighted that we are in an era where it's kind of appreciated and cherished that such green solutions for the water is happening, and not also the profit is a lucrative form. We are curious what will happen, and let's stay curious and inspired. Thank you for the attention, and if you have any question, let me know. Thank you.